All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to work through these elimination homework problems and I will solve the odds. The expectation is that you follow along and solve the odds and then you try your hand at the evens. Okay, the ones I'm going to grade tomorrow will be the odds, but you will eventually tomorrow be assigned the evens. So if you want to be the kind of student that gets ahead, the kind of student that's on task, you'll go ahead and get the entire homework assignment done. The good news is elimination is much simpler than substitution. It seems to be easier for students to do, so let's dive in and let's get these done as quickly as possible. In the first system of equations, we're given y equals negative x plus 1 and y equals 4x minus 14. So the way we set this up starts by rewriting this system. I like to rewrite the systems. I don't like to work over with these little numbers and these curly Q brackets. It gets in the way. So let's rewrite the system. Y equals negative x plus 1. And below that, we'll write y equals 4x minus 14. And remember to keep these numbers lined up. Everything's got to be lined up. Let's draw a line here. And we have to determine what to do with our problem. We have to establish a kind of game plan, okay? So we have to eliminate one of the variables, either y or x. So just this first problem will take just a moment. If I focus in on the y variables, if I add y plus y, I get 2y. So I haven't eliminated the y variable. Okay, similarly, if I add negative 1x and 4x, I get 3x. So I would fail to eliminate either the y or the x variable if I add. So addition is not going to work. We only have two options. We can either add or subtract. So let's try subtraction. First, let's focus here on the x's. If I subtract the x's, if I say negative 1x minus 4x, then I have negative 5x. So again, I failed to eliminate the x variable, so that didn't work. Let's try the y's. 1y minus 1y is 0. Okay, y minus y is 0. So that would work. If I use subtraction, I can eliminate the y variable. So this is my game plan over here. I'll say eliminate, and I'll just abbreviate that ELIM, eliminate y by subtraction, which I'll write SUB. Okay, so I'm going to eliminate the y variable by subtraction. So I'll say, come over here and write a minus sign. And now we're going to apply this to the entire problem. We're going to work in columns. So first, y minus y. Y minus y is 0, so let's write 0 here. And now we'll bring down the equal sign. And now this is where I want to be careful that we understand that in between the negative sign, or the minus sign here, the negative sign here, and the x, there is an understood 1. So watch how I do this with my finger, and you should do this and say this out loud, or at least in your own mind. I actually will say it out loud. Negative 1x minus 4x. So negative 1x minus 4x gives me negative 5x. So negative 1 minus 4 is negative 5. So negative 1x minus 4x is negative 5x. Now, 1 minus negative 14. Okay, if I write this, it looks more clear. 1 minus negative 14. And this is one of the big landmines, okay? So watch out. 1 minus negative 14, that's a double negative, so I need to come in here and change this to a plus sign. Okay, so it's not 1 minus 14, right? If you were just looking at the column, you would make the mistake, 1 minus 14. But if we say 1 minus negative 14, you see it's 1 plus 14, so it's actually positive 15 that goes right here, plus 15. Okay, and from here, we solve for x. So now I'm going to solve for x. Solve for x. Okay, so I have 0 equals negative 5x plus 15. If I want to get x by itself, I have to do a reverse order of operations and start by subtracting 15 from both sides. Okay. On the right side, 15 minus 15 is 0, so these are gone. 0 minus 15 is negative 15. And that equals negative 5x. The negative 5x just comes down. And now I have to do whatever the opposite operation would be. So right now, negative 5 is multiplied by x, so I need to divide both sides by negative 5. Remember, what I do to one side, I must do to the other. So divide both sides by negative 5. Okay, so on the right side, these negative 5s cancel, and I have x equals. So let's look at the left side of the equation. Forget about the negative signs for a moment. Just divide 15 by 5. 15 divided by 5 is 3. So negative 15 divided by negative 5, a negative divided by a negative is a positive, so negative 15 divided by negative 5 is positive 3. So 3 equals x, or x equals 3. So you have solved part of the system. Remember, a system solution will be a coordinate pair x comma y, and so you found that x is 3. And now the question is, what do we do with this? What's the next step? Well, if I need x and y, I better find y. I know what x is, so I can actually plug x back into either of my equations. If you look at the two equations, one of them is going to be simpler to work with than the other. And that would be the top equation. So we can write here, not y equals negative x plus 1, but y equals negative 3 plus 1. Because x is 3. So you just plugged 3 in where x is. So now we have to say, what is negative 3 plus 1? Well, negative 3 plus 1 is going to get more positive by 1, so y equals negative 2. Now you found both parts. You found that y is negative 2 and that x is 3. So the solution to the system where these two lines would cross in a coordinate plane is at 3, negative 2. That's number 1. We'll move faster here on number 3. Okay, so let's first ask ourselves, let's first write the equations out. X minus 2y equals 10. And x plus 3y equals 5. Being careful to line everything up. X plus 3y equals 5. We'll draw a big line here. And now the question we have to see first is, do we have common coefficients? Coefficients are the numbers in front of the letters. Do I have common coefficients anywhere? And the answer is yes, I do. I have a common coefficient in front of each x. All right? There's a 1 there. It's just understood. So what would I have to do to eliminate the x variable? If I add 1x plus 1x, I get 2x, so that's not going to work. So my game plan is going to be to eliminate the x variable using subtraction. So I'm going to use subtraction to eliminate the x variable. 1x minus 1x is 0. And now let's be very careful here. I have negative 2y minus 3y. Negative 2y minus 3y. Side work is a very good way to keep yourself out of trouble. Negative 2 minus 3 equals, negative 2 minus 3 equals negative 5. I'm going to get more negative because I'm taking 3 away from negative 2. So I need to write, if negative 2 minus 3 equals negative 5, negative 2y minus 3y equals negative 5y. And now I move to the final column, 10 minus 5. Okay? So it's really helpful to use your finger. You'll always get it right. 10 minus 5. 10 minus 5 is 5. So we bring down this equal sign, and then 10 minus 5 is 5, so I put 5 here. Okay, so now at this point we will solve for y. Okay? Now how would we do that? I would need to divide both sides of this equation by negative 5. We can ignore the 0. Divide both sides of the equation by negative 5. The negative 5's cancel on the left, and I have y equals 5 divided by negative 5, which is negative 1. And now I can plug this number back into either of my two equations. In this case, it doesn't really appear that there's much of a difference. I'm going to choose the bottom equation, since in the last problem we chose the top. And what I'm going to do is write x plus 3. And I'm going to stop and think, what is y? So I'm not going to write y. I'm going to write what y is, and y is negative 1. So in this case, I'll have to put it in an open parentheses, negative 1, close parentheses, equals 5. And now let's just solve for x. All right, so x, and now before you write plus, think about it. 3 times negative 1 is negative 3, so we'll write x minus 3 equals 5. To get x by itself, I just need to add 3 to both sides of my equation. Negative 3 plus 3 is 0, so x comes down and it is by itself, and x equals 5 plus 3, which is 8. So now I have both components of my solution, x equals 8 and y equals negative 1. So the solution to the system, x comma y, is 8 comma negative 1. Let's put that in a box. Okay, next problem. Let's go ahead and get it written out. X plus y equals negative 4. And x minus y equals 2. Let's draw a line. And let's ask ourselves, do we have common coefficients anywhere? Now, it might be tempting to think that you have common coefficients with the y's, but you really don't. Because remember, there's a 1 in front of, it's an understood 1 coefficient in front of all of these variables that don't have any coefficients in front of them. Notice here on the y that it's positive 1y up here, but down below it's negative 1y. So those are different. Positive 1 and negative 1 are different coefficients. But I do have common coefficients with the x's. They're both 1s. So in this case, I would just, to eliminate them, eliminate the x's, I'd subtract them from one another. Okay, so my game plan is to eliminate the x variable by subtraction. So focusing in here on the columns, one at a time, let's do the x's. 1x minus 1x is 0. So x minus x is 0. Now the second column is the middle. 1y minus negative 1y. Let's write it out. 1 minus negative 1. Okay? Landmine, watch out. That's really 1 plus 1. And that gives us 2. So if 1 plus 1 is 2, or 1 minus negative 1 is 2, then 1y minus negative 1y is positive 2y equals negative 4 minus 2. Negative 4 minus 2. What does that equal? Well, we're taking 2 away from negative 4, so it's going to become more negative. Negative 4 minus 2 is negative 6. So if negative 4 minus 2 is negative 6, then negative 4 minus 2 is negative 6. We'll put the negative 6 right here. Okay, so now I've got the equation down to 2y equals negative 6. It's just a one-step process to get y by itself. I just have to divide both sides by 2. Okay, we'll cancel the 2's on the left, and I have y equals negative 6 divided by 2. Negative 6 divided by 2 is negative 3. So now I've found out that y is negative 3. Well, what am I going to do with that? I have to plug this y value, negative 3, back into one of my equations. Okay, and we'll just eeny, meeny, miny, mo. Okay, we'll do the bottom equation. We have here x minus, okay, let's stop there. Open parentheses, negative 3, close parentheses, equals 2. So x minus negative 3. Well, there's 2 negatives there. They become a positive. So it's x plus 3 equals 2. Well, if x plus 3 equals 2, I need only subtract 3 from both sides to get x by itself. I've got 3 minus 3. Those cancel. So x comes down. X equals 2 minus 3. 2 minus 3. I take 3 away from 2, and that leaves me with negative 1. So I have here x is negative 1, and y is negative 3. So the solution to the system, x comma y, is negative 1 comma negative 3. Let's move on to number 7. First, before we think, let's write, get it written out, negative 3x minus 4y equals negative 1. And below it, we'll write 3x minus y equals negative 4. Okay, let's draw a line and go ahead and help ourselves out by putting that invisible 1 in front of the y there. And let's start looking at it. Do we have common coefficients anywhere? Okay, not in front of the x, we've got a negative 3 and a positive 3. And not in front of the y, we've got a negative 4 and a negative 1. But let's think about this for a minute. Let's try subtraction. All right, that's what we've been doing so far. Negative 3x minus 3x is negative 6x. So subtraction doesn't work on the x. Negative 4y minus 1y is negative 5y. So subtraction didn't work on the y. Well, the only other thing we can try is addition. Let's see if it works. Negative 3x plus 3x. All right, let's come over here I kind of wrote too far to the right, so I'll do my side work over here. Negative 3 plus 3. Well, that's 0. That works. See, if I try to eliminate the x variable by addition, I succeed. Okay, so we're going to do addition this time. Negative 3x plus 3x is 0. Negative 4y plus negative 1y. All right, again, side work. Negative 4 plus negative 1. Well, plus negative, in the epic battle between plus and minus, minus always wins. So we just say negative 4 minus 1. Well, that's negative 5. So if negative 4 minus 1 is negative 5, then negative 4y plus negative 1y is the same thing as saying negative 4y minus 1y, and that gives us negative 5y. Let's bring over the equal sign. And now let's do the final part. Negative 1 plus negative 4. So that's negative 1 plus negative 4. Negative 1, and then rather than writing plus negative, the epic battle between plus and minus, minus always wins, we'll write negative 1 minus 4. Okay, and that equals negative 5. So negative 1 plus negative 4 is negative 5. And now I just have one step to get y by itself. Divide both sides by negative 5. On the left, the negative 5's cancel, and we have y equals. And now I have negative 5 divided by negative 5. Well, anything divided by itself is 1. Doesn't matter if it's positive, negative, letters, numbers. Negative 5 divided by negative 5 is positive 1. Okay, so we have y. We just need to plug it back into one of our equations. Let's use the bottom one. It looks easier. So I have here 3x minus, and then instead of writing y, we'll write 1, equals negative 4. So here's my equation I need to solve for x. 3x minus 1 equals negative 4. So now my process is to add 1 to both sides. Negative 1 plus 1 is 0, so they cancel out, and I have 3x equals, and now I do negative 4 plus 1. So I'm adding 1 to negative 4. It's going to become more positive, and so that would be negative 3. Final step, divide both sides by the x coefficient, which is 3. Okay, so x equals negative 3 divided by 3 is negative 1. So now I have x equals negative 1 and y equals 1. So the solution to the system of equations, x comma y, is negative 1 comma 1. Let's put that in a box. And remember, this is where two lines will intersect on a coordinate plane. If we graph these two lines, they would intersect at negative 1 comma 1. All right, so now we're ready to flip the page. Number 9. Let's get it written out. Let's write 3x minus 4y equals negative 14. And beneath that, we'll write 3x plus 2y equals negative 2. And I'm going to draw a big line here. And now we have to do our analysis. Do we have common coefficients anywhere? Yep, right in front of the x. So when I've got these common coefficients, if I try adding 3x plus 3x, I get 6x. But if I subtract 3x minus 3x, I succeed in eliminating the x variable. So our game plan is to eliminate the x variable by subtraction. Just put a subtraction there. Okay? And remember, we're going to work in columns. In class, I actually took the time to draw in this kind of dotted barrier that would help you remember to keep those columns separated. If that helps you, go ahead and do it. So we're going to work in columns. 3x minus 3x is 0. So we've eliminated the x variable. Now, be careful here. Negative 4y minus 2y. All right? Negative 4 minus 2. What does that equal to? Well, I'm taking 2 away from negative 4, making it a larger negative number. So that would be negative 6. So if negative 4 minus 2 is negative 6, negative 4y minus 2y is negative 6y. Okay, what does that equal? Well, now let's follow. Be very careful here, because here's a landmine. Negative 14 minus negative 2. I highly recommend doing this side work every time until you're super comfortable. Negative 14 minus negative 2. Now I've got a double negative here, so I'll make that a plus. Now I have negative 14 plus 2. Okay, what is negative 14 plus 2? Well, I'm adding 2 to negative 14, making it a more positive number, which would be negative 12. So over here, negative 14 minus negative 2 is negative 12. And now I'm one step away from having y by itself. I just divide both sides by negative 6. The coefficient of the y variable, negative 6. So on the left, these cancel out, and I have y by itself equal to negative 12 divided by negative 6. A negative divided by a negative is a positive, and 12 divided by 6 is 2. So y equals positive 2. And now I just have to plug it into one of my two equations. Looks like the bottom one has smaller numbers, so we'll give that a try. So remember, I found y, so I'll write 3x plus 2, and then I'll stop, and I'll do an open parentheses and put a 2. Okay, in there for the y equals negative 2. And remember, when you write a number next to a parentheses, it means multiply. So let's write 3x again, plus 2 times 2 is 4, and that's equal to negative 2. And now we will subtract 4 from both sides. Okay, on the left side, these cancel out, and I have 3x equals negative 2 minus 4 is negative 6. So 3x equals negative 6, and we'll divide both sides by the coefficient of the x variable, which is 3. Okay, so I'll run out of space here, so I'll write x equals negative 6 divided by 3 is negative 2. Okay, so now I have x equals negative 2 and y equals 2. So the solution to the system of equations x comma y is negative 2 comma 2. That's where these equations would intersect in a coordinate plane, or these equations when graphed would intersect in a coordinate plane. Okay, now on to number 11. In number 11, we have a brand new problem. Okay, so we have to stop, We have to think and pay close attention, or we will run ourselves right smack into a jackpot. So notice that we have 5x equals y plus 6. 5x equals y plus 6 in the top, and then in the bottom we have 5x plus 2y equals 3. Now, you cannot proceed with this problem until you first get the equations in exactly the same form. All right, so what we have to do is get this top equation to look like the bottom equation. And that means we have to move this y over to the left side of the equal sign. So before we do anything else, we have to solve the top equation, or we have to rearrange the terms in the top equation. So let's write 5x equals y plus 6. All right? Now I want that y to go over on the left side of the equation, so I'll have to subtract y from both sides. Okay? So pay close attention here because this is new. This is something we have not done before. All right? So let's pay close attention here. On the left side, on the right side of the equation, y minus y, those cancel out. And on the left side of the equation, I can't mix those terms, so I'll just write 5x minus y equals, and the only thing left on the right side of the equation is 6. All right? So now I have 5x minus y equals 6. This is in the same form as this equation here. Okay? So now that I've rearranged the equation on top to make it look like the equation beneath it, now we can proceed with the process that we've been doing so far here. We can write 5x minus y equals 6. And that's the rewritten form of the top equation. Okay, so now in the bottom equation, I'll write 5x plus 2y equals 3. Okay, so this was a crucial step that we did here. If you didn't do it this way, you'll probably get the problem wrong. Now let's draw our line, and let's think about which one we want to eliminate. Well, if I subtract the x's, 5x minus 5x, I do eliminate the x variable. So we'll solve this system by eliminating the x variable using subtraction. Okay, so now 5x minus 5x is 0. And here I need to go in and put my 1 in between that negative sign and the y. Negative 1y minus 2y. Right, so let's do a little side work. Negative 1 minus 2. Negative 1 minus 2 is negative 3. Okay, so negative 1y minus 2y is negative 3y. Bring down the equal sign. And now I have 6 minus 3. Well, 6 minus 3 is 3. And now I will divide both sides by the y coefficient of negative 3. Okay, so cancel out those negative 3's, get y by itself. Y equals 3 divided by negative 3 is negative 1. Y equals negative 1. All right, so now I'm just going to plug it back in to one of my original equations. Doesn't matter which one, but I've got y by itself up here, well, no coefficient anyway in the first equation, so that will be the easier equation. So I'll go up here and write 5x equals And then instead of writing y, I'll write -1 plus 6. Okay, so 5x equals, and -1 plus 6 is +5, because I'm just subtracting 1 from 6. And now I'll divide both sides by the coefficient of x, which is 5. Okay, so cancel, cancel. Now x equals 5 divided by 5, which is 1. So now I have x equals 1 and y equals -1. All right? Okay, so our solution to our system, x comma y, is 1 comma -1. And that's what we put in the box. Okay, next up we have number 13. And in number 13 we have the same problem we had in number 11, where you don't have these equations in the same form. 6x minus 3y equals -21 is not in the same form as 4x equals 3y minus 9. So you can model one equation after the other, but I'd suggest taking the second equation, the bottom equation, and getting the 3y to come over here on the same side of the equation as the x variable, so it looks like the top equation. So let's do that. 4x equals 3y minus 9. And the very first thing we need to do here is subtract 3y from both sides. On the right side, those cancel. And on the left side, I have two different variables, so they don't mix. So I'll just write 4x minus 3y equals -9. And now I've got the equation in a form that is similar to the equation beneath it, or the equation above it, okay? So what we'll do now is we will write 6x minus 3y equals -21. And beneath it, I'll write my newly rewritten equation, 4x minus 3y equals -9. And the reason we do that is so that all these variables line up and the equal signs line up. Okay, so now let's go through our process. Which variable do we want to eliminate? Well, you might be conditioned to think it's always going to be the first variable, but look what happens. If I take 6x minus 4x, I still have 2x. So I can't eliminate the x variable through subtraction. If I add them, it's 10x. Doesn't work. Looking here in the middle, I have -3y. If I add them, I have -3y plus 3y plus -3y. Okay, -3y plus -3y. What does that equal to? Well, in the epic battle between plus and minus, minus always wins. So let's see if I can get rid of that plus sign there. So what is -3y minus 3y? Well, it's actually -6y. All right, so that is no good. All right, we don't want to use that method. So we can't use subtract, we can't use addition. Let's try subtraction. -3y minus -3y. Let's see what that looks like. Let me just stick with the coefficients this time. -3 minus -3. Oops, can't see it. Okay. Now, we have a double negative, so these become a positive. -3 plus 3 is 0. So let's think about what we just did. We used subtraction to eliminate the y variable. All right, so that's what our game plan is going to be. So let's go through this one piece at a time, starting from the left. 6x minus 4x is 2x negative 3y minus negative 3y is 0. All right? So those are eliminated now. Now let's do this one. Negative 21 minus negative 9. Okay. Negative 21 minus negative 9. Okay, what does that equal? Well, we have a double negative again. This is a harder problem, isn't it? So we have negative 21 plus 9. So what are we doing here? We're adding 9 to negative 21. Well, on paper, the way you would do that without a calculator is you would treat it like a subtraction problem. You would say, well, what is 21 minus 9? Well, you can't take 9 from 1, so you would borrow from 2, turn the 2 into a 1, and the 1 into an 11. And you would say, well, 9 from 11, 11 minus 9 is 2, okay? And 1 minus nothing is 1. So 21 minus 9 is 12. So negative 21 plus 9 is negative 12. All right? So that was a bit involved. Negative 21 minus negative 9 is negative 12. So let's put the equal sign here and the negative 12. Lots of landmines here in this problem. This is a difficult problem. So now we can simplify to 2x equals negative 12. And now I just divide both sides by the x coefficient of 2. Okay, cancel, cancel. And we have x equals negative 12 divided by 2, which is negative 6. So now I have the x part of the solution, and I just need to plug it back into my equation to find the y part. And I can pick any equation. Well, I'm going to choose the bottom equation here. Doesn't matter, right? But they have smaller numbers. I don't want to deal with that 21 right there. So I'm going to use this bottom equation. So I'll write 4, open parentheses, negative 6, close parentheses, equals 3y minus 9. Okay, so 4 times 6 is negative 24. Negative 24 equals 3y minus 9. And now I have to add 9 to both sides. Okay. On the right side, the negative and the positive 9 cancel out. And on the left side, I have the same problem I was doing before, kind of, where I've got negative 24 and I'm trying to add 9 to it. Well, that's the same thing as doing subtraction, but putting a minus sign in front of the result. So let's do this over here. 24 minus 9. Okay, borrow from the 2, make it a 1, make the 4 into a 14. 14 minus 9 is 5, and 1 minus nothing is 1. Okay, so if 24 minus 9 is 15, then negative 24 plus 9 is negative 15. So negative 15 equals 3y. Well, now what? Well, now we have to divide both sides by the coefficient of y. So I'm kind of bleeding over into the next problem a little bit here. But there was a lot to write. We divide both sides by 3. The 3's cancel on the left. And I have negative 15 divided by 3 or on the right. And I have negative 15 divided by 3 on the left. Well, negative 15 divided by 3 is negative 5. Therefore, okay, I have y equals negative 5. So let me show you what we got here. We have x equals negative 6 and y equals negative 5. This was a very challenging problem. And so my solution here is negative 6, x comma y, negative 6 comma negative 5. Okay? I would say that that was top level challenging. All right, just look at all the math. It's crazy. Okay, so final problem, number 15. Okay, so we've got the same situation. We need to rearrange our equations to make them look the same. Well, this time I'll do something a little bit different. I'm going to make the top equation look like the bottom equation. And the way I'm going to do that, I'll rewrite the top equation here, x plus 3y equals 5. And what I'm going to do is get x by itself here for a second. So I'll do that by subtracting 3y from both sides. The 3y's cancel here, and I have x equals negative 3y plus 5. Okay, so I've rewritten this top equation to look like the equation beneath it. So what I'll do now is I'll go up here, but you know what I could do is simply take yes for an answer here and just write the second equation right beneath this one rather than rewriting both of them. Let's see if that turns into some kind of nightmare. So I'm going to write that second equation here, x equals negative 6y plus 14. Okay, so let's put our big line here. And now let's figure out which one of these variables are we going to eliminate. Well, if I do x minus x, I get 0. So we'll eliminate the x variable by subtraction. X minus x is 0. Write the 0, make sure you write the 0, equals, and now be very gentle and be very careful, negative 3y minus negative 6y. So over here in side work, which I guess I'll put up here, I have negative 3 minus negative 6. Okay, if you write the side work out, you'll never get it wrong. So I've got this double negative here that needs to become a positive. These are real tricky, so be careful. Now, negative 3 plus 6, that's the same thing as 6 minus 3. It's positive 3. So if negative 3 plus 6 is negative 3 minus negative 6 is positive 3, then negative 3y minus negative 6y is positive 3y. And now 5 minus 14. Okay, well 5 minus 14 is the same thing as saying 14 minus 5, but we're going to make the answer that we get negative after we get it. So I can't take 5 from 4, so I have to borrow, turn the 1 to a 0 and the 4 into a 14. And now 14 minus 5 is 9. Okay, and so if 14 minus 5 is 9, then 5 minus 14 must be negative 9. Well, now I'll just add 9 to both sides, trying to get y by itself. On the right side, the 9's cancel, and on the left side, I have 0 plus 9, and that's 9, equals 3y. Okay, let me divide both sides now by 3. On the right side, the 3's cancel, and on the left side, I have 9 divided by 3. Now, 9 divided by 3 is 3. So 3 equals y. Okay, and now I just need to plug this y back in somewhere, okay, and solve for x. Well, our second equation already has x by itself, so let's go back here and say, where do I want to do this? I'll do this right here. X equals negative 6, open parentheses, 3, close parentheses, plus 14. So x equals negative 6 times 3 is negative 18 plus 14. Okay, so now x equals negative 18 plus 14 is negative 4. So x equals negative 4 and y equals 3. So the solution to the system of equations x comma y is -4 comma 3. And we'll put that in a box. And that is the solution to the system. So now we've solved all the odd problems, and at a bare minimum, you will come into class tomorrow with all of the odd problems solved, because you have here a video with all of the solutions to the odd problems from this first eliminations homework assignment. All right, so it was all humming along very nicely until we got to 11, 13, and 15. So I'm guessing that 12, 14, and 16 might have some of those landmines. So pay careful attention when you're working those even problems, whether it's tonight or over the weekend or in class tomorrow. Make sure that you're paying close attention. There's a lot of math here. You know, if I wasn't recording this video like this, I would almost certainly have preferred to do all of these problems on separate sheets of paper, so I'm not so cramped. You know, I don't like being all cramped in like that. It's almost impossible. I had a student this morning saying, I can't tell what the first thing you did was, and then the second thing you did, and the third thing you did. And that's a good point. I mean, there's just stuff written all over the place, and that's a byproduct of the fact that I'm having to cram it all into this box. And I would much prefer to have some nice, clean sheet of paper to work on, and I probably would have filled up at least a half a page, if not a whole page, for every single one of these problems. That's my tendency, to write big and be orderly, but having to cram it in like this is just unfortunate. Okay, well now let's start this little wind down process here. If you found this video helpful, the very least that you could do is give it a thumbs up and leave a comment. All right, leave a comment that says something like "this helped," or "thank you," or "I appreciate this," or "I hated this." Okay, "I hate you," "this class sucks," "I hate math." All right, "my career as a mathematician is never going to happen," or "I am definitely going to become a rocket scientist as a result of watching this video," or "I watched this video and then I went out and created a business that made me a billionaire and now I don't have to go to school anymore." Right? Something, right? Give me something in the comment section. If you have a legitimate question, post it in the comments. I'll be sure to answer it. Also, please make sure that you have subscribed to the channel. I release videos almost every day on this channel, and it's going to help you to be subscribed, especially if you hit that notification bell so you're always alerted to new videos on this channel. Finally, I just want to say thank you. If you have taken the time to watch this video to the end, thank you for your attention. It means a lot to me, and I promise, while it seems like torture now, this will all pay off in the end. Thanks so much.